Hello everyone, my name is Dongwon Choi from KAIST AI. Today I would like to introduce our research with Kumo AI, RDB2G Bench, a comprehensive benchmark for automatic graph modeling of relational databases. Relational databases or RDBs are widely used in many industries. Recent advances leverage graph-based ML for RDB prediction tasks. For example, on RDB schema, is modeled as a graph with table rows as nodes and foreign key relations as edges. Then, by training graph neural networks, we can obtain a final prediction for the downstream task. But there are several options during this modeling. First, some table rows are more natural to be modeled as edges between tables, which we refer to as row-to-edge modeling. Also, some tables or F-key relations may not be useful for a given task. In such cases, we can drop them from the graph. Based on design choices, RDB2 graph modeling aims to find a graph model that maximizes the performance of the predictive GNN for a given task. Careful RDB2 graph modeling is crucial in practice. For example, if we compute a graph model from a common approach and an optimal one, then optimal RDB2 graph modeling achieves noticeably higher performance in practice, demonstrating the importance of graph modeling. However, RDB2 graph modeling is non-trivial because there are many possible graph models. And evaluating each modeling choice is computationally costly, requiring repeated GNN trainings. To address these challenges, we introduced RDB2G Bench, the first benchmark designed for automatic RDB2 graph modeling. Next, I'll describe the dataset we constructed for RDB2G Bench. We built our dataset based on 5 real-world RDBs and 12 predictive tasks from RelBench, a popular benchmark for machine learning on RDBs. To enumerate all possible graph models from RDBs, we first select which tables and foreign key relationships to include in the graph, and then select how to represent the rows of each table, whether to model them as nodes or as edges in the graph. By doing so, we constructed about 50,000 distinct graph models across various RDBs and tasks. For each constructed graph models, we collected its predictive performance, runtime, and parameter size as evaluation metrics. With pre-computed evaluation metrics in RDB2G Bench, we can immediately obtain a graph model's performance without running costly evaluation again. From now on, I'll share several observations from our dataset briefly. First, we found that finding the best graph models is worthwhile with better performance, lighter training time, and parameter size. Second, modeling table rows as edges or row to edge can be crucial. Third, top performing graph models tend to share common substructures. Fourth, different tasks may require different graph models even within the same RDB. Lastly, the effectiveness of graph models generalize across different predictive GNNs. Next, I'll move on to the benchmark part of RDB2G Bench. Using our dataset, we benchmarked 10 RDB2 graph modeling methods, including heuristic-based, action-driven search, and LLM-based approaches. Now, I'll summarize the benchmark results. This plot shows the average rank of each method depending on the time budget. First, most baseline methods outperform a widely adopted heuristic even under minimal budgets. Second, value-based search algorithms such as greedy forward search and Bayesian optimization improve with larger budgets as they learn from accumulated performance feedback. Third, LLM-based methods work well with small budgets thanks to their contextual reasoning, but their relative ranking drops as the search space grows. Lastly, this plot shows the time saving by our RDB2G bench dataset. Using pre-computed metrics in RDB2G bench enables evaluation up to 389 times faster compared to the on-the-fly evaluation with Juyeon training. Finally, I conclude the presentation. RDB2G bench is the first benchmark for automatic RDB2 graph modeling, offering large-scale datasets, fast evaluation, and useful insights for future research. That's all for my presentation. Thank you for listening.